There is a plant growing in the ditch behind your house right now that produces 6,000 pounds of flower per acre. That is not a typo. 6,000 pounds from 1 acre, without planting, without fertilizer, without irrigation, without any human input whatsoever. Wheat produces 400 pounds of flour per acre under ideal conditions with full industrial support. This plant produces 15 times more, grows on every continent, spreads itself, harvests itself, and humans have been grinding it into bread for 30,000 years. You have walked past it 1,000 times. You thought it was a weed. In 2010, a team of researchers published findings in the Proceedings of the National Academy of Sciences that quietly dismantled the standard story of human civilization. Anna Reverdin and her colleagues had examined ancient grinding stones from 3 archaeological sites, one in southern Italy, one in Russia, one in the Czech Republic. These stones dated back 30,000 years, and embedded in their surfaces, preserved in the microscopic crevices of the rock for 300 centuries, were starch grains. Not wheat starch, not barley starch, not any grain that agriculture had ever produced. The starch came from plant roots, specifically from a wetland plant that still grows across the northern hemisphere today. A plant so common, so ubiquitous, so completely ignored by modern food systems that most people have never considered eating it. The plant was typha, the cattail, the brown hot dog-shaped plant growing in every marsh, every roadside ditch, every farm pond, and every neglected wetland across the continent. The plant you have driven past 10,000 times without a second thought. Your ancestors thought it was dinner, not occasionally, not as a survival food of last resort, as a primary staple, as the foundation of a food system that predated agriculture by 20,000 years and outproduced it by a factor of 15. Think about what those grinding stones actually mean. Women in Ice Age Europe were processing cattail rhizomes into flour while mammoths still walked the earth. They had sophisticated food technology. They understood starch extraction. They understood fermentation. They understood how to convert a wild root into a storable, portable, calorie-dense food source. And they passed that knowledge down through hundreds of generations. The standard story of human civilization begins with agriculture, the Fertile Crescent, domesticated grains, settled villages, 10,000 years ago. But those grinding stones predate all of that by 20,000 years. The story did not begin with farming. It began with a plant that never needed to be farmed, because it was already everywhere, already producing, already waiting. Before we talk about the yield numbers, you need to understand what kind of plant the cattail actually is, because it is not behaving like any crop you have ever grown. Typha latifolia, the broadleaf cattail, and its close relatives Typha angustifolia and the hybrid Typha x glauca, are obligate wetland perennials. They grow in marshes, lakesides, drainage ditches, and seasonally flooded depressions at elevations below 1,500 meters. They are found on every continent except Antarctica. They colonize new wetlands through wind-dispersed seeds, each flower head producing up to 300,000 seeds that travel miles from the parent plant. And once established, they spread through underground rhizome networks that expand outward year after year without any human assistance. This is not a plant that needs you. This is a plant that has been managing its own reproduction, its own expansion, and its own soil preparation for millions of years. The erenchyma tissue in its stems, large longitudinal air pockets that transport oxygen from the aerial leaves down to the submerged rhizomes, allows it to maintain high metabolic rates in waterlogged anaerobic soils where every conventional crop would suffocate and die. Even the dead stalks of previous seasons continue transmitting oxygen to the root zone, ensuring that the rhizomes survive prolonged flooding and initiate rapid growth in early spring. Research conducted in Minnesota measured cattail growth rates at 30 to 40 grams per square meter per day for over 2 months. That is a period of sustained productivity that is unusual for any agricultural crop. The upright sword-like orientation of the leaves maximizes exposure to direct sunlight while minimizing self-shading. The proximity to water allows the plant to utilize reflected sunlight from the water surface, enhancing its total photosynthetic capacity beyond what any terrestrial crop can achieve. The plant is classified as invasive in many jurisdictions. Government agencies publish management guides on how to kill it, herbicide recommendations, mechanical removal techniques, controlled burns. They are spending money to destroy a plant that produces 15 times more flour per acre than the crops they replaced it with. Now the numbers. Because this is where the cattail story stops being interesting and starts being important. The specific quantification of cattail productivity, approximately 6,000 pounds of flour per acre, originates from the work of researcher Harrington in 1972, who estimated a yield of 6,475 pounds of flour per acre from a healthy stand. But the most expansive data comes from the Cattail Research Centre at Syracuse University, established in 1947. Lead researcher Leland Marsh reported that in optimized stands near Wolcott, New York, it was possible to harvest 140 tons of fresh rhizomes per acre. When processed, those 140 tons of fresh roots yield approximately 32 tons, or 64,000 pounds, of dry cattail flour. Let that number settle for a moment. 64,000 pounds of flour per acre. Compare that to the benchmarks of modern industrial agriculture. Wheat yields 2,000 to 4,000 pounds of grain per acre, of which 70 to 80% becomes flour. That gives you 1,400 to 3,200 pounds of wheat flour per acre under full industrial management, with purchased seed, with synthetic fertilizer, with pesticides, with irrigation, with annual replanting. Potatoes, often cited as the most productive food crop in temperate agriculture, yield 20,000 to 40,000 pounds of tubers per acre, of which roughly 20% is starch. That gives you 4,000 to 8,000 pounds of potato starch per acre. The cattail, growing wild in a roadside ditch with zero inputs, produces more starch per acre than potatoes under intensive cultivation. And it does it without anyone planting it, feeding it, watering it, or harvesting it until the moment you decide to. The starch content explains the productivity. Cattail rhizomes contain up to 70% starch by dry weight. That rivals pure cornstarch. The caloric density of cattail flour matches wheat flour, almost exactly at 266 calories per 100 grams. The protein content at 6 to 8% compares favourably to rice and maize, and unlike most wild foods, cattail flour contains meaningful amounts of manganese, vitamin K, magnesium and dietary fibre. This is not a survival food. This is a nutritionally complete staple crop that grows itself. The archaeological evidence from Italy, Russia and the Czech Republic is not an anomaly. It is the tip of an iceberg of global human knowledge about this plant that spans every continent and every culture that ever lived near water. In North America, the cattail was so vital to indigenous life that it was called the supermarket of the swamp. The Apache used the pollen in complex ceremonies. The Cahuilla Indians of California utilized the stalks for matting and bedding. The Pomo, the Navajo, the Lumbee, tribes from the Atlantic to the Pacific, processed cattail rhizomes into flour for millennia. Around Lake Titicaca in South America, the same traditions developed independently. Different continent, different culture, different language, same plant, same solution. In southwestern Australia, the Noongar people developed what anthropologists now describe as a form of incipient agriculture around Tifa, known locally as Yanjay. They managed cattail stands through controlled burning during the dry season to clear old foliage and improve the quality and sweetness of the roots for the subsequent harvest. Women used digging sticks called wana to extract the rhizomes from the margins of drying lakes in autumn. The rhizomes were cleaned, slowly roasted in hot ashes, and pounded into a mass formed into cakes. Explorer Thomas Mitchell noted in 1836 that these cakes were lighter and sweeter than those prepared from common flour. In Mesolithic Europe, archaeobotanical evidence from the late Mesolithic Ertebøl settlement at Tjebryn Vig in Denmark, dated 5,600 to 4,000 BC, indicates a diet rich in aquatic and coastal resources where starchy roots like those of the cattail were collected alongside seabeat and acorns. In these cultures, the availability of typha provided a stable caloric buffer during late autumn and winter when other forage was scarce. Different continents, different cultures, different languages, same plant, same solution, same 30,000-year track record. This was not regional knowledge. This was universal human knowledge, the most widely distributed, most consistently utilized, most independently rediscovered food plant in human history. And somehow, In the span of a few generations, the modern world forgot it completely. The cattail does not produce 6,000 pounds of flour per acre by accident. It produces it because of a set of biological adaptations so precisely suited to starch accumulation that no agricultural breeding program has come close to replicating them. The rhizome is the key, the horizontal underground stem that spreads outward from the parent plant, sending up new shoots and storing the energy reserves that allow the plant to survive winter and initiate explosive spring growth. That rhizome is essentially a starch battery. The plant spends the entire growing season converting solar energy into starch and packing it into the rhizome for storage. Because the cattail is a perennial, it does not need to allocate energy to seed production the way annual crops do. An annual wheat plant must produce enough seed to reproduce itself and provide a harvestable surplus. The cattail reproduces through rhizome expansion and through its prodigious seed production simultaneously. It does not have to choose between reproduction and starch storage. It does both at maximum capacity. The wetland environment amplifies this productivity. Water is never a limiting factor. Nutrients from agricultural runoff, the nitrogen and phosphorus that drain from surrounding farmland and would otherwise cause toxic algal blooms in downstream water bodies, are captured by the cattail and converted into biomass. The plant is not just producing food, it is cleaning the water while it does it. Research confirms that cattail stands can remove 30 to 60 kilograms of phosphorus per hectare per year from contaminated water. Constructed wetlands planted with typha are used in wastewater treatment systems across Europe and North America precisely because of this nutrient capture capacity. The plant that produces 6,000 pounds of flour per acre is simultaneously performing the water purification function that municipalities spend millions of dollars on with mechanical systems. The C-type crystal structure of cattail starch, a rare combination of the A-type polymorphs found in cereals and the B-type polymorphs found in tubers, gives it functional properties that make it suitable for a wide range of food applications. Its amylopectin is more highly branched than corn or potato starch, offering advantages as a thickener and in the production of adhesives. The flour contains minerals including iron, phosphorus, potassium and magnesium, along with vitamins B6, C and niacin. And modern pharmacological research has identified something even more remarkable. Controlled studies involving rat models with induced colonic damage demonstrated that dietary supplementation with 10% cattail rhizome flour was as effective as the steroid prednisolone in reducing intestinal inflammation. The flour's efficacy is attributed to its high concentration of flavonoids, saponins and coumarins that act as antioxidants and inhibit pro-inflammatory enzymes. The plant that feeds you is also treating the inflammation that modern processed food causes. In the 1940s, as the United States faced potential disruptions to traditional food supplies during World War II, the strategic value of cattail productivity was formally recognized by the American government. Plans were developed to harvest cattail starch to feed American soldiers. The Cattail Research Center at Syracuse University was part of a broader Commergy movement, a field of science dedicated to finding industrial and food applications for abundant but neglected plants. Researchers confirmed that typha could serve as a viable alternative to cornstarch or wheat flour in large-scale food production. They confirmed that over 50% of the solids could be converted to ethyl alcohol, projecting a yield of approximately 285 gallons of alcohol per acre, positioning cattail as an ideal feedstock for fuel that does not compete with food crops for prime agricultural land. The war ended before these plans could be fully implemented. The research was published, it was cited, and then the momentum stopped. Not because the plant failed, because the industrial food system that emerged from the post-war economic boom had no mechanism for monetizing a plant that grew wild, spread itself, required no purchased inputs, and could be processed with nothing more than water and a bucket. A wartime survey conducted by the United States government mapped cattail distribution across the country. They found 140,000 square miles of cattail swamps, an area larger than Germany, growing wild, producing no economic value in the industrial sense, classified as wetland habitat or, worse, as invasive nuisance vegetation requiring expensive control measures. 140,000 square miles of the most productive flower plant on Earth, classified as a problem to be managed rather than a resource to be harvested. Here is the part that makes this plant genuinely accessible to anyone. Because the processing method requires no equipment that was not available 30,000 years ago. And it still works today. The harvest window is late autumn through early spring. This is when the plant has drawn its energy reserves down into the rhizomes for winter storage, and the starch concentration is at its maximum. The rhizomes are found 6 to 24 inches below the surface of the mud, spreading horizontally outward from the base of the plant. Step 1 is identification. The cattail is unmistakable when mature with its distinctive brown cigar-shaped flower spike. But in early spring, before the spike forms, it can be confused with the blue flag iris, which is toxic. The reliable distinguishing feature is the cross-section of the leaf. Cattail leaves are D-shaped in cross-section, flat on one side and rounded on the other. Iris leaves are flat and symmetrical. Check the cross-section before harvesting anything. Step 2 is extraction. Wade into the shallow margin of the stand and locate the rhizomes by feel in the mud. They are white, firm, and roughly the diameter of a finger, running horizontally just below the surface. Pull them free from the mud, following the rhizome outward from the base of the plant. The rhizome regrows after harvest. The colony expands whether you harvest it or not. Step 3 is cleaning and peeling. Wash the mud from the rhizomes and peel away the fibrous outer layer with a knife or vegetable peeler to reveal the white starchy core. Step 4 is starch extraction. Break the cleaned rhizomes into a bowl of cold water and work them with your hands for approximately 20 minutes. The starch releases from the fibrous matrix and clouds the water. The fibers float, the starch sinks. Step 5 is sedimentation. Allow the milky liquid to sit undisturbed for 3 to 24 hours. The starch granules settle to the bottom as a dense white layer. Pour off the water and the floating fibre carefully. Step 6 is drying. Spread the wet starch on a flat surface and dry it in the sun or in a low oven. Once dry, grind it to a fine powder. The result is a pale, slightly sweet flour that can be used directly in flatbreads, pancakes, and as a thickener for soups and sauces. Many foragers blend it 50-50 with conventional flour for baked goods. The flavour is mild with none of the bitterness that characterises most wild food experiments. And in early summer, the plant offers a second harvest that requires no processing at all. The male flower spike produces massive quantities of bright yellow pollen before it releases. Shake the flower heads over a container and collect a protein-rich powder that functions as a flower supplement. 1 plant, 2 food products, 0 inputs required. The global flour market generates $260 billion annually. Wheat flour alone accounts for 44% of that market. Farmers buy seed every spring. They buy fertilizer. They buy pesticides. They buy irrigation equipment. They harvest once per year and then start the cycle again. Cattail does not fit this model. Plant cattail once and it spreads on its own through underground rhizomes. It requires no fertilizer because it thrives on nutrient-rich runoff that would kill other crops. It requires no irrigation because it grows in standing water. It requires no pesticides because few organisms attack it. And it cannot be patented because it is a wild plant in the public domain. A permanent food source generates 0 recurring revenue. 0 recurring revenue attracts 0 corporate investment. 0 corporate investment means 0 marketing budget. And 0 marketing means 3 generations of humans grow up without ever learning that the most productive flower plant on Earth grows in the ditch behind their house. The transition of typha from a survival plant to a commercial staple would require specialized harvesting equipment, capable of operating in saturated soils, food safety standards regarding heavy metal levels in plants harvested from potentially contaminated water, and market integration utilizing the unique properties of cattail starch in gluten-free and health-conscious food sectors. Typha species are highly effective at phytoremediation, absorbing and storing heavy metals from contaminated water. This makes them potentially hazardous to consume if harvested from polluted areas such as drainage ditches near industrial sites, agricultural areas treated with pesticides, or urban runoff channels. Proper site selection is essential. Clean water sources, natural wetlands and farm ponds away from chemical inputs produce safe, nutritious rhizomes. The plant's ability to clean contaminated water is a feature for environmental remediation. It is a risk for food production in the wrong location. Harvest from clean water. The plant will tell you what it has been absorbing. 30,000 years ago, a woman in Ice Age Italy knelt beside a marsh, pulled a white root from the mud, and ground it into flour on a stone. She was not surviving. She was eating better per acre of land than any wheat farmer in human history. The cattail did not disappear because it failed. It disappeared because it could not be sold, because it grows where it wants, spreads without permission, and produces food without asking anything from the person who harvests it. The most productive flower plant on Earth is growing right now in every roadside ditch, every farm pond, every neglected wetland margin on every continent in the temperate zone. It has been growing there for millions of years. It will keep growing long after the wheat fields go fallow and the grain silos rust and the flour mills close their doors. 6,000 pounds of flour per acre. No planting, no fertilizer, no irrigation, no supply chain. Just water, mud, and a plant that has been feeding humans since before we knew what farming was. The knowledge was never lost. It was just forgotten. And every time you walk past a cattail stand without recognizing what you are looking at, you are walking past the most productive food system that ever existed. Subscribe. Every week we uncover the plants, the systems, and the forgotten food knowledge that the modern world buried. Not because it stopped working, but because it could not be monetized. The cattail is in the ditch. It has always been there. The only thing missing is the person who remembers what it is.